what do we have in chapter 7? Chapter 7, ya shabab, is about, it's still about trigonometric functions, but it is more about the trigonometric identities and the trigonometric formulas and trigonometric equations. So we have here 5 sections. In the first section, we will just see how to prove or verify trigonometric identities. In the second section, we will have, inshallah, addition and subtraction formulas and the double and half angle formulas in the 7.3. And in the last 2 sections, we will study, inshallah, the trigonometric equations. Let's start with 7.1. What is this section about? What are the objectives here? What you will learn? You will see how to simplify trigonometric expressions by using the fundamental identities. If you remember the fundamental identities that we have mentioned in chapter 5 and also in 6.2. We will see also how to prove trigonometric identities. There is a caution here that before using or before studying this, it is related to proving this. What we mean by proving here. To prove an identity, we do not perform the same operations on both sides of the equation. We will see that when we solve or prove some identities. So what we will start with, ya shabab, is the identity. What is the identity? The identity, it is an equation. You know, you have 2 sides. This is the left hand side. This is the right hand side. Like any equation. But what is special about it? What is special about the identity that it is always true for all the values of the variables. Like what? Like when you say, for example, here, when we say, let me give you an easy example. Is it identity or not? For example, I think we have here some examples. No, we don't. Good. So I will give you here an example. So when we have cosine x equals to 1, is this identity or equation? Who can tell me? Is it identity or equation? Is it true for all the values of x? Is it true for all the values of x? It is equation. Who said it is equation? Why it is not identity?
It's me. I said it's equation because if x was any number other than 0 or 180 and overall n multiplied by pi, I think then it's wrong.
So indeed, you are right. X here, shabab, is what? X here is 0 or what? Cosine 0 is 1. Or it is what? It is 2 pi. No, be careful. Cosine pi is not 1. Cosine pi is -1. So it is just like this. 4 pi, and it is the even pi's, okay? Okay, so this is not identity, ya shabab. Muhammad, thank you, Muhammad. Now, what about this? Cosine squared x plus sine squared x equals to 1. Is this identity or equation?
This is identity.
This is identity, ya shabab. Whatever x is, this is true. Whatever x is, it is true. Sometimes we can exclude some x values if we are in within the domain. Yani if for some, like for the tan, it is not. It is for all x, for all the values for all the values of the variables. Let's say in the domain, to be more accurate. So of course we should be within the domain. Let me ask you the last question, Shabab, because this is a common mistake. I noticed that some students, they use this. Is this identity or equation? Cosine x plus sine x equals to 1. Is it identity or equation?
Equation, it's not identity.
Is this always true?
No.
No.
No. This is always true. So this is not always true, ya shabab. This is only true for some specific values of x. For example, here x, of course, we wait until 7.4 and 7.5. We will solve this equation. Okay. Now the trigonometric identity, ya shabab, it is the identity that involve trigonometric functions. So we will not study new identities, by the way. We will start with the fundamental identities that we have studied before. You remember this? The reciprocal identities and the Pythagorean identities, and of course the even odd identities. You can add, of course, this is for also for cosecant, for cotan, for secant. So what I advise you to do here, also add cosecant. Cosecant negative x, it is negative cosecant x. Secant negative x, it is equals to secant x. And of course here cotan negative x, it is equals to negative cotan x, because these are the reciprocal of these. Okay, so it must be clear. No need, of course, to repeat that. Also the co-function identities. So these, ya shabab, are the fundamental identities that we have studied so far. This is so important, the co-function identities. It is tricky ones. So you have to be able to apply them. This is for any x, by the way, ya shabab. Whatever x is, it is true, not only for the two angles that their sum is pi over 2. We have generalized that in 6.2. Now, let's see how to simplify trigonometric expressions by using these identities. Now, look at this expression. How to simplify it. So if someone, ya shabab, if someone tells you that this is equals to secant t, are you going to believe him? Do you think this equals to secant t? All of this equals at the end to secant t?
No.
Believe it or not, it is equals to secant t. So how to show that? You need to simplify. And of course, to simplify, you need to use these identities. These are your tools. So look, what we will do. Cosine, we have cosine, tan, sine. So if we are going to do something, we will do it with what? With tangent. What is tangent? What is tan t?
Sine over cosine.
Sine over cosine.
Sine over cosine. So what we did, we left cosine and sine as they are. Now tan t, it is sine over cosine. Look what we have now. We will do just the algebraic tricks that we know from before, from 001, 002. So we have here sine t over 1. So multiply now. Sine times sine, it will be sine squared. 1 times cosine, it will be cosine. Just we multiply this by this, numerator by numerator, denominator by denominator. Now we have two fractions. Here we have one also in the denominator. So we will make them a single fraction. What is that? We will unify the denominators. So we will make both of them over cosine t. So we will multiply cosine by cosine. So it will be cosine squared plus sine squared over cosine of t. What is this in the numerator, ya shabab? What is this?
1.
This is 1. So we have here 1 over cosine t. What is 1 over cosine t?
Secant.
Secant t. So all of this equals to secant t. So this is an identity. This is true. This is true for all t, for all the possible values of t. Here, because we have tangent, we cannot have the denominator equals to 0. So it is for all t in the domain of these functions. Good. So we have now cosine t plus tan t, sine t equals to secant t. We simplified this as much as we can, and we of course know this is so easy and so simple. Secant t equals to all of these. They may ask you, of course, to prove that this equals to this, and it will be much easier, of course, if you know what you want. Excellent. What you will have, for example, you will have 5 choices. If they give you this, They will give you 5 choices to choose one of them. So what you will do, you will simplify this as much as you can. Then you will compare it with the results that you have. Let's take another exercise. Again, look at this. If someone else tells you that also this equals to secant t, it is not easy to believe him, ya shabab. How this will be equals to secant t? So don't say yes, don't say no, don't say possible, don't say impossible until you see what will happen. So what you will do, you will try to simplify this. So now we don't have tangent, we don't have cotangent, we don't have cosecant or secant. We just have sine and cosine. So how to simplify this, ya shabab? What we will do to simplify this?
Denominator.
Mansour, yes, you are right. You mean we have two fractions. You know, Shabab, when you have a over b plus c over d, usually it is natural to write them as a single fraction like this to unify the denominators. Okay, to write them as a single fraction. So this is a good idea. Now, what is the LCD? The LCD will be this numerator multiplied by this numerator. This is the common denominator. And it is here, it is the CD indeed, the common denominator. The common denominator is this. Now, of course, to make them a single fraction, you need to multiply this by this and this by this. So we have what? We have here sine theta multiplied by 1 plus sine and cosine multiplied by cosine, which is cosine squared. Now expand here, you need to expand also. So this will be the next step. So it will be sine theta plus sine squared theta plus cosine squared theta over all this. You have to be careful, Shabab, and be smart. What is this?
1.
This is 1, so you will replace it by 1. Look, just as it is, but this is equals to 1. Don't forget, this is plus 1. Now, do you notice something now? What we have in the numerator
You can cancel
is the same as we have in the denominator. These are the same. So cancel this with this. What you will have? Here you will have 1, here you will have 1. Here it will be 1 over 1 times cosine is cosine. So you will have 1 over cosine, which is what?
secant.
Which is secant theta. Amazing. All of this at the end is equals to secant theta. Okay? طبعا sometimes, Shabab, sometimes you can go back. You can, if you have this, you can write it like this, but it is not easy, of course. Usually we start from the complicated one to get the simpler one, not the opposite. But it is not impossible. Any question, Shabab, how to simplify expressions? So what you need to do, Shabab, you need to use the trigonometric identities that you know so far. You need to use your algebraic tricks that you learned from before, how to simplify, how to cancel, how to distribute, how to take a common factor, how to, and so on. All the algebraic tricks that you used before. By the way, we have here some guidelines for you, how to prove identities. So for example, what we mean by proving here. The proving, Shabab, they will say, prove or verify that this equals to secant theta. So now you know what you want. You want to prove that this equals to this, or this equals to this. It is the same, equivalent. So to prove, what you need to do, you need to start with one side. Don't work on both sides. So it is, of course, here practical to choose the side that is more complicated. So your goal is to transform it into the other side. It is usually easier to start with the more complicated side. This is a very important trick. If they are equivalent in the complexity, you can of course choose any side. In the second step, what you will do, you will use known identities. Let me repeat this. You will use known identities, not your own identities, because I have noticed some students, they use strange identities. I don't know from where they bring them. So use known identities, not your own identities. Then use algebra, of course, and the identities you know to change the side you started with. Bring fractions fractional expressions to a common denominator, which means unify the denominators, factor, use the fundamental identities, and simplify. In the last one, if you are stuck at some stages, then you can convert to sine and cosine, as we did with the previous example, the first example. So if you are stuck, you may find it helpful to rewrite all functions in terms of sine and cosine, because ya shabab, if you notice from the fundamental identities, everything can be converted to the original functions, sine and cosine. Everything is coming from sine and cosine. Tangent, cotangent, secant, cosecant, quotient. The procedure, shabab, of verifying identities is not the same as solving equations. What does that mean? When we solve equation, shabab, you have two sides. You can add to both sides. You can multiply both sides. You can subtract both sides. Here we will not do that. Here we don't have them equals. When you prove that they are equals, you need to prove that this equals to this. So don't use the equality here. I think it should be clarified like this. To prove an identity, we do not perform the same operations on both sides. So we don't multiply both sides by a number. We don't add two numbers unless we are already done with the proving, of course. Let's take an example. Verify that this equation is identity. So prove this, in short, prove that this side equals to this side. So we need to prove that cosine theta times secant theta minus cosine theta equals to sine squared theta. So we cannot do, ya shabab, here, مثلا, you cannot say divide both sides by cosine theta. This is wrong. If you did this, this is wrong. Why it is wrong? Because you need to prove that this equals to this, not to use it. So you need to show me, you need to start with this, then show me that it is equals to this. So forget, if you choose one side to start with, forget about the other side at the beginning. Just you need to recall it at the end to compare it with what you want. So here, shabab, we need to remember the guidelines. So we need to start with one side. What do you think? What is the side that it is better to start with? The left-hand side or the right-hand side?
Left-hand side.
Usually we will write this for short LHS, left-hand side. And this one we will call it the right-hand side. So it is, which one is the more complicated one? The left-hand side. So we will start with the left-hand side. This is the left-hand side. Now, what we can do, use known identities. So what do you think? What is the identity that we can use here?
Secant is 1 over cosine.
لا منصور ما شاء الله عليك يا منصور اليوم منصور مصحصح اليوم. Okay, Mansoor, secant theta, it is what? It is 1 over cosine. So you are totally right. Secant, it is 1 over cosine. Because, ya shabab, this is at the end, it is cosine. What we can do for it? It is original function. So good. Now, what we will do next, ya shabab, anyone other than Mansoor?
Multiply cosine by 1 over cosine equals 1.
Yes. Distribute or expand. Thank you, Migdad. So,
and then minus cosine square, that's all the fraction equals sine square theta.
We will multiply cosine by the first term and by the second term. You know the distribution rule. So we will distribute it. Now, when we distribute, look what we'll have. Cosine multiplied by cosine, it will be 1. Minus cosine multiplied by cosine, it is cosine squared. What is 1 minus cosine squared?
Sine squared.
It's sine squared, yes, because you know that sine squared theta plus cosine squared theta is 1. So if you move the cosine to here, you will have sine squared. Great. So we showed that this left-hand side equals to the right-hand side, and we have proved this identity. Look, we didn't use this at all from the beginning because we need to prove it. I think now you are aware about what we mean by proving identities, or verify or prove. Now we need to show that 2 tan x secant x is 1 over 1 minus sine plus 1 over plus sine. what do you think, ya shabab, here? Which side is better to start with? The left-hand side or the right?
The right side.
You are right. This is the more complicated one. Okay, so we will start with the right-hand side, and we will prove that it is equals to at the end to the left-hand side. It is the same, طبعا. You can start with the left. So this is usually the students start with this one, the one on the left. No, it is not necessary. So I think he will start with the left, with the right. Let's see. Did he start with the right? Yes, with the right-hand side. Yes, Amigdad.
Yes, Doctor. We will
Yes.
make the difference between two squares.
No, I
one-
didn't ask yet, Amigdad. Wait until I ask, please. I didn't ask how to do that. But what I was expecting from Migdad to ask is, what about if we start here? We can, of course, ya shabab. Sometimes we can, sometimes it is not. We will see that together at the end. When we finish this, we will see, it was possible or not to start with the right-hand side. So we will start with the left, with the right-hand side. Now, what we can do here, shabab, we have two fractions with basic function, which is sine. So here we will do what, as Migdad mentioned, we will make them a single fraction. We will bring them over the same common denominator. What is the common denominator? It is this multiplied by this. And you know, when you have 1 minus, so what we will do, this will be equals to what? This is the common denominator. Now this will be multiplied by this, so it will be 1 plus sine x minus this multiplied by this. Don't forget here the negative, be careful. Here we have minus, this is the minus. Now 1 multiplied by 1 minus sine x. When you expand now, 1 minus sine by 1 plus sine, what is this? Here. 1 minus sine multiplied by 1 plus sine. It is 1 minus sine squared. Difference of squares, as you mentioned before. This is, ya shabab, difference of squares. You need to remember a minus b times a plus b. It is a squared minus b squared. So here a is 1, b is sine x. Now here you will simplify 1 plus sine x minus 1. Negative times negative is positive, sine x. Now you can see clearly that we have here positive 1 and the negative 1. So these will be cancelled. And what we have here? Here we will have 2 sine x, 2 sine x over, what is 1 minus sine squared?
Cosine squared theta.
It is cosine squared, yes, by using the Pythagorean identity. Now you have to stop here and look, where are you going? So remember, what is your target? This is our target, Shabab. This is what we want to have at the end. So are we close from this or we not? We are not. 2, we have 2. This is good news. So this is equals to 2. This is the 2. Now cosine squared, you know, Shabab, what is a squared? A squared, it is a times a. So here we have, let's write it like this. Here we have what? Cosine x times cosine x. Okay? Now this is sine x. So here we have times 1 times sine x. Is that right? 2 sine x. It is 2 times 1 times sine x. Now this is 2. This is 2. What is 1 over cosine?
Secant.
Secant. What is sine over cosine?
Tan.
So we have 2 secant tan or tan secant because the multiplication is commutative. If you want, you can write it like this. This is 2 sine x, and of course 2 sine over cosine is tan, if you want to write it with the same order. And this is 1 over cosine, which is what? Which is secant. Now this is exactly the left-hand side. Let me show it to you here and to see if it is, of course, possible to start with the left-hand side or not. Here we are, Shabab. This is exactly what we have done. I preferred, of course, to do it for you step by step. Now, Here, ya shabab, you will feel the beauty of mathematics when you do it in the right way. Now, this is all what we did. Now, if we were starting from here, it was possible to get there? Sometimes we can, sometimes we cannot. So if you start with the left-hand side, you will write tan as sine over cosine, secant as 1 over cosine. Then you will multiply numerator by numerator, denominator by denominator. You will write 1 cosine squared equals to 1 minus sine squared. But from here to here, I think, ya shabab, you will not think about it. It is not easy. So here, it is not easy to go from here, to go from this step to this step. It is not easy. For this, they are easy. So this is why it is very important to start with of course, the more complicated part. Any question, ya shabab, about this? Let's take another example. طبعا, if an expression contains 1 plus sine x, multiplying both numerator and denominator by 1 minus x would give 1 minus sine squared, which is of course cosine squared. Similar process, ya shabab, will convert, can be applied for 1 minus sine, 1 plus cosine, 1 minus cosine. This is very easy trick here, ya shabab. If you notice, because this equals to this, look here, when we multiply 1 minus sine by 1 plus sine, we will have 1 minus sine squared, which is cosine. This might be helpful, ya shabab, in many cases, like here. Prove this identity. How to prove this identity? Indeed, both sides are, let's say, are equivalent in the complexity. There is no one more simple than the another one. But you have to decide which one you will start with. What do you think, Shabab? We will start with the right-hand side or the left-hand side?
I think the right-hand side is much better.
You can, I do agree with you. You can start with the right-hand side or with the left, by the way. But let me show you. Let's see what he did, and we can do both. So he started with the left. No problem. So what we can do for the left, ya shabab? We will apply what is mentioned here. So for the left, you have 1 minus sine. So what you will do, you will multiply by the conjugate. If you remember the idea of the conjugate, as we said, if you have 1 plus sine, multiply by 1 minus sine. If you have 1 minus sine, multiply by 1 plus sine. Why is that? Because this times this will give you 1 minus sine squared. 1 minus sine squared, it is cosine squared. This is what is good. So now in the denominator, we have 1 minus sine squared times 1 plus sine squared, which is 1 minus sine squared, which is cosine squared. This one is cosine squared. Now we can cancel this with the squared because we have 2 here. We have cosine u times cosine u. So this will be cancelled with one of them, and we left up with one only in the denominator. This has been cancelled with. So we have now 1 plus sine over cosine. Remember what you want, ya shabab. We want this. We want this at the end. This is our target. So now we can do what? Who can tell me? What we can do here?
You can multiply by.
No.
It's 1 over cosine. Let's separate the fraction.
Separate. This is the word that I want to hear. Yes, separate or distribute. Then the two numerators over the common denominator. So here what we will do, we will separate into 2 fractions. It is 1 over cosine plus sine over cosine. 1 over cosine is what?
Secant.
Secant. Sine over cosine is what? Tan.
Tan.
So we are done. We proved our identity. Now let's see, Shabab. I don't remember. I think who said we will start we can start with the right-hand side. Yes, we can. Let's see. Assume that we started with this. Can we prove that it is equal to the another side? Let's see. From here to here, it is easy. Secant, it is 1 over cosine. Tan is sine over cosine. Then from here to here, it is also easy. Now here we are. Here, what we to do, if you have 1 plus sine u over cosine u, it is not easy to go from this to this, Shabab. Here, what we did, we multiply by cosine. and divide by cosine. So cosine multiplied by cosine, this cosine squared and this cosine. Then convert cosine to 1 minus sine squared. Then write this as this times this. This, of course, will be, so I think, ya shabab, we did the right thing to start with that. Okay? So it was better to start with the left-hand side here, not the right. Again, I mentioned here when we multiply this, why we do that usually. Now, let's see here how to prove this identity, how to prove that this equals to this. If you look at them, indeed, both of them are complicated, but I believe that this is more complicated. Do you agree with me? So it is, in my opinion, it is particular to start with the right-hand side and prove that it is equals to the left-hand side. We will do that, inshallah. But let's see what is this about. He started with the left-hand side. So this is not what we was planning to. So indeed, in such problems, let's see what we have. Let's see what we have. Now we have 1 plus cosine over cosine. What we can do here, Shabab? We will, sorry, we can separate here. It will be 1 over cosine plus cosine over cosine. 1 over cosine is what? Secant. Cosine over cosine is 1. So are we close now from what we want? Is this similar to what we have here? No. So we may stop here. Okay. Sometimes, ya shabab, when you have right-hand side and left-hand side, you need to prove that they are equal to each other. Sometimes it is not easy. You cannot get this here. So what you can do, you can work on the left-hand side until you have let's say expression. Let's say you have E, something here, expression. Then you will work on the right-hand side to have the same expression. So if you can do that, this means what? This means that the left-hand side equals to E and also the right-hand side equals to E. So both of them are equal to each other. So in fact, this is a very interesting trick. So how to prove an identity by working on both sides separately. So we will work on this until we get something simple. Then we will work on this one until we get something like this. So how to do that? We will stop here, Shabab, now. I can tell you what you can do after that, but let me stop here. Now, take this now, work on this, on the right-hand side. You have tan squared over secant minus 1. What is tan squared? Do you remember what is tan squared? Tan squared, the identity. Tan squared theta plus 1 equals to secant squared theta. So according to that, what is tan squared? Tan squared theta will be what? Move 1 to there. It will be secant squared theta minus 1. So what we did here, we just replaced tan squared by secant squared minus 1. Now, what is secant squared minus 1, ya shabab? Algebraically, compare it with this. What is a squared minus b squared? It is difference of squares here. So secant squared minus 1, it is just secant theta minus 1 times secant theta plus 1. Difference of 2 squares. Now this will be cancelled with this. And what we have at the end? We have secant theta plus 1. So the LHS equals to secant theta plus 1, and also the right-hand side equals to secant. So these are equals to each other. If A equals to B and C equals to B, then this means that A equals to C. Clearly. So we proved by a new technique that these sides are equal to each other. And this is, ya shabab, very helpful in many cases. Okay? But of course, this must be used when you can reverse, when you can go back, of course, when you can prove this by back like this. Of course, we should be able to do that. طيب, this is, ya shabab, not the only way that we can use. Again, this method can be used when the steps are reversible, when you can reverse the steps, like you will go back. We can do that here. Let me, Shabab, give you another trick. But this is just an example about how to work on both sides. Indeed, I was able here to continue. Look, what can I do here? What I can do to get this? I can multiply by secant theta minus 1 over secant theta minus 1. The problem is, how can you think about it? Is it going to, are you going to think about this, or this idea, it will come to your mind or not? In fact, from where this idea comes to my mind? From here. Look what I have in the, look what I have in the denominator here. This is my target. So I did just multiply by 1. Yani. I have this expression, I multiply it by 1. What is that 1? It is not any 1, it is a hero 1. My hero here is secant theta minus 1 over secant theta minus 1. Now, secant theta plus 1 multiplied by secant theta minus 1, what is it? It is secant squared theta minus 1, difference of squares, over secant theta minus 1. Now, what is secant squared minus 1? It is tan squared theta over secant theta minus 1. And this is equals to the right hand side. We can prove this directly. And if you can do that, it is better. But if you cannot, you can stop and go and simplify the other side. Okay? Now, do you know that we can also prove that we can start with this and then prove that it is equals to this? Who can help me with that, Shabab? Tan squared theta over secant theta minus 1. It is equals to what? I think we have it here. We have it like here. Now we can do that. I put a hint for you. Yes, you can start with the right hand side, rewrite it in terms of sine and cosine, and then simplify. So one way, because if you look at this, what you have here, you have tangent and secant. What you have here, you have cosine. So it is I think practical, very practical, to convert these functions to sine and cosine. So let me do that here. We have tan squared theta over secant theta minus 1. Tan squared is what? It is sine squared theta over cosine squared theta. Over secant theta is what? It is 1 over cosine theta minus 1. It is equals to, now, yeah, Shabab, be careful here. It is, let me write it as it is. Sine squared theta over cosine squared. Now, this is the common denominator. Here what we have? 1 minus cosine theta over all cosine theta. Just I unify the denominators in the denominator. This is the main fraction bar, yeah, Shabab. So you need to remember, when you have A over B, all over C over D. What is that? This is indeed A over B divided by C over D. So it is A over B multiplied by D over C. So this is equals to what? Sine squared theta over cosine squared theta multiplied by what? By the reciprocal, by cosine theta over 1 minus cosine theta. Good. Now here we will have what? This cosine will be cancelled with the square. And we will have here what? Sine squared. What is sine squared? Sine squared, it is 1 minus cosine squared over this cosine theta multiplied by 1 minus cosine theta. But as you can see, Shabab, it is not simpler, the one that we used. Now, 1 minus cosine is 1 minus cosine theta times 1 plus cosine theta. My target is this, remember, over cosine theta multiplied by 1 minus cosine theta. Now this will be cancelled with this, and we will have at the end 1 plus cosine over cosine, which is this. We proved that the right hand side equals to the left hand side, but ya Shabab, bringing these two sides to the middle is much better here. Just do 2 or 3 steps there and go there on the other side and do the same. let's see now how to use also these identities. يا شباب in math 102 إن شاء الله إذا وصلتوا لmath 102 and you will إن شاء الله. You know math 102 is about integrals mainly, how to integrate. In in this course there is something that is called the trigonometric substitutions. So when you want to find this integral, how to find the integral of this function, how to find this integral, to do that you should use the trigonometric substitution. What are the trigonometric substitution? It is about looking at this like 1 minus sine squared. So you will put x equals to sine theta. So you will put x equals to sine theta. So this is why they call it trigonometric substitution. So if you put x equals to sine theta, look what you will have. You will have square root of 1 minus sine squared. What is 1 minus sine squared? It is cosine squared. Under the square root, who can tell me what is this equals to? What is this? The square root of cosine theta equals to what? The square root of cosine square theta equals to what, ya shabab? Hello? Hello? Are you still there, ya shabab?
Yes,
Yes.
it's cosine.
Yes, sir.
Anyone other Migdad other than Migdad and Mansour? Where are the people? Hello? What is the square root of y squared?
Cosine.
So this is equals to cosine theta. Who said that? Jasser?
Yes.
Thank you, Jasser, but this is not completely true.
Absolute value.
Absolute value, ya shabab. Please, please, please. We don't know. We don't know where is x. We don't know where is theta. But here in this case, where is theta? In general, the square root of cosine square theta, it is the absolute value of cosine theta. But you need to ask yourself now, cosine theta, is it positive or negative? Okay. Is this, if this is positive, you will remove the absolute value. If it is negative, you will write it negative cosine. So how to know? Where is theta? Theta, it is between 0 and pi. He gave me here. So because theta is between 0 and pi, so in which quadrant it is? So it is in quadrant number 1. In quadrant number 1, cosine is what? Positive. So this is indeed without absolute value is correct. And finally, Jasser is right. But of course, you have to be careful. It is not because it is in general not true, but for this specific example, it is true because theta is in the first quadrant. Now, we are done, ya shabab. This is 7.1. As I told you, shabab, this section is related to what we did before more than what we will do later. So what you need to remember from this section mainly is how to prove identities. These 3 guidelines for you to do that. And of course, the fundamental identity. Let's now practice by solving some old exam questions. Let me give you, Shabab, 2 to 3 minutes to solve this, please. This question, I have noticed that it is the most repeated question in the old exams. I removed many similar questions in the old exams, but I have noticed that the trick here, it is repeated several times. So please, Shabab, write it down. Write this sine x over 1 plus cosine negative x plus cosine negative x over 1 minus tan x, and try to prove that it is equal to this. You can take a photo for these identities. Maybe you need one of them to use if you don't have them. Yeah, Shabab, I advise you to print these out and put them in front of your office, in front of your bed, on your table, always to remember them, because you will use them a lot. Not only this, of course, all the identities. From these identities, we can have like 10 identities from these. Yalla ya shabab. And I will launch polling for you if you want to practice. Really practice, ya shabab, to check that you understood today's class or not. This is, I think, one good example to end up with. Who can give us a hint, ya shabab, how to start with this? Who
Can I
has,
try?
give me a hint, just the hint. What is the first step?
For cosine and cotan, they are even and odd functions, so you can get rid of the x inside.
Allah يرضى عليك يا محمد وعلى والديك. Yes, this is the best hint that we can have, ya shabab, for this question. So as Muhammad said, here the first step is to write this as sine x over 1 cotan, ya shabab, odd or even? It is even, so it is odd. So this negative will go out. So it will be 1 minus cotan x plus cosine is even. So it will be just equals to itself without negative over 1 minus tan x. This is the first step, ya shabab. So this is step number 1. Now continue. I need another hint from another student, please. Not from Muhammad, from anyone else. What we can do next?
You
Yes,
expand
Khalid.
the cotan and tan in the beginning.
Khalid, again, please.
You expand the tan and the cotan in the beginning. Make it sine over.
Repeat that. What do you mean?
I mean, you make the tan in terms of sine and cosine, and the cotan in terms.
Exactly. Yes. Write tan and cotan in terms of sine and cosine. Thank you, Khalid. Yes, let me just mention that here because I should mention that Khalid also has the right answer. And of course, Muhammad. Excellent. Now, this will be equals to sine x over 1 minus. Yeah, let me ask مين عقل, are you here, عقل رميزان? Yes, cotan. What is cotan?
Cosine over sine.
Cosine x over sine x. Thank you. Plus cosine x over 1 minus. What is tan, يا عقل?
Sine over cosine.
Ahsant. Excellent. Thank you. Now let me ask someone else who I need to choose some students that I didn't ask so many times. Hamoud Twajri. Hamoud, are you here?
Yes, here.
What we can do next, يا حمود?
We can نخلي الكسر نفسه يعني sin over sin يصير الواحد.
So this is the numerator, the common denominator is like this. هذه المين fraction bar.
Yes.
So what you mean, we will simplify this. We will make it a single fraction.
Yes, right.
It will be all over sine x. What we will have here? Sine
Sin negative cosine x.
minus cosine.
Cosine x.
Thank you,
And-
Ahmed. You're right.
And the same with the second fraction.
We will do the same here. So it will be cosine x over, this is the main fraction bar. Be careful. It will be cosine x minus sine x over cosine x. What we will do next? Let me ask Muhammad al-Ubaid. Yeah, Muhammad, do you know what we can do next? Muhammad al-Ubaid, are you here, Muhammad? Muhammad al-Ubaid. He's here, but he's not responding. So I will mark him absent. You are absent, ya Muhammad. Okay, let me now ask who? Yasir al-Liyami. Yasir.
Yes.
What we can do next, ya Yasir? Let me remind you.
Doctor, I thought about multiplying like by sine x.
Good idea, not bad, but this is much easier. Yes, you're right. So it is a over b. When you have a over b over c,
Yes.
like this. How to write it? This is indeed a divided by what?
Sine squared x.
No.
Sine squared x over sine x minus cosine x.
Yasir. Follow here. About a, b, and c.
Yes.
Forget about it. When you have a divided by b
Okay.
over, it will be what? A times what?
C over B.
So this is exactly what we will do here. So this is my A, this is
Yeah.
B, C.
Sine squared x over sine x minus cosine x.
Yes. So this is sine squared.
Yeah, that's what I just said.
There. Yes, I know, but I want to clarify it for your colleagues also. Now this will be plus.
okay.
We will do the same here.
Cosine squared.
But ya shabab, be careful. Be careful. What is the main fraction part? What is the numerator? What is the denominator? For example, if it is like that, look at this. I will write it here. But if it is like this, let me use another color. If it is A over B all over C, this is something different. This will be A over B divided by C. This will be A over B multiplied by 1 over C. So it will be A over BC. While here it is AC over B. So but look at that. So you need to be careful which one is the main fraction part. So this will be cosine squared x over cosine x minus sine x. Okay, let me see how the progress so far. So I can see that like 6 students answered so far. Now what?
Yeah, I accidentally put another answer, doctor. By the way, I solved it correctly, but I entered the answer.
So what is the benefit of your solution if this is happening in the exam? When you bubble a wrong answer, be careful. So
No, this is different. This electronic, this one.
No problem. So it is almost the same, but no problem. This is not the target. The target is to practice how to solve,
Okay.
not to choose the right answer here. Now what we can do next, ya shabab? Do we have the same numerator? Here we have sine
Yes.
minus cosine.
Wait.
Here we have why we have it like this, please. Now we have okay. We have now do we have the same denominator? Because here we have two fractions. Indeed, here we have sine x minus cosine x, and here we have cosine x minus sine x. You know that a minus b is the same as minus or negative b minus a. We know that. So what we will do here, look what I will do. Let me solve it here. I will do this. This is equals to sine squared x, and here it will be minus. This is sine x minus cosine x, and this also will be sine x minus cosine x. What I did, I just wrote cosine x minus sine x as sine minus cosine, but with a negative. So this becomes negative. And here we have cosine squared x. This will be equals to sine squared minus cosine squared, sine squared x minus cosine squared x over sine x minus cosine x. Now, what is sine squared minus sine squared? We know that sine squared plus cosine squared is 1, but sine squared minus cosine squared, it is what? It is difference of two squares. So it is cosine minus cosine multiplied by sine plus cosine, all over sine minus cosine. Let me write it here for you. So it will be sine x minus cosine x multiplied by sine x plus cosine x, all over sine x minus cosine x. Now this will be cancelled with this, and we have this at the end. The answer is B, as most of you, by the way, most of you answered or choose the right answer. This is good. Okay, now you can, ya shabab, as I said, this trick is repeated so many times in the old exams. Now, in the remaining 3 minutes, we need to see just a hint about how to prove that this equals to that. What we can do to prove this equals to which one of these? What we can do? What we can do here? What
Put
is
them in sine and cosine, in terms of sine and cosine.
You are right, Jasir. Yes. Write these in terms of cosine and sine. And I have the solution here for you, Shabab. So you will write cosecant as 1 over sine, cotan as cosine over sine, tan as sine over cosine. Now you will simplify. Be careful when you simplify, because here it is about a plus over b plus c over d all over and so on. So you have here what is called complex fraction. When you work with complex fraction, you have to be careful. So this is the main fraction bar, ya shabab. Now simplify the numerator as much as you can. Simplify the denominator as much as you can. So this is what we did. This is the numerator, the main numerator. This is the main denominator. Now what you can do more, you can say that this is equals to 1 plus cosine over sine. This is the numerator. Multiplied, it will be multiplied, you know, when you have a over b all over c over d, this is equals to a over b multiplied by d over c. This is what we did. Now, of course, this will be cancelled with this because sine here is a common factor. So you will have cosine over sine squared. So it will be 1 over sine, cosine over sine. 1 over sine is cosecant, cosine over sine is cotan. And this means that the right answer is what? Is the first one. Interesting. Let's see another one. Okay, this one. How to prove that? No, this is a tricky question indeed, but it is not that tricky. He wants you to prove that this side equals to this side, but indeed it will be equals to this side with some numbers, a, b, and c. So a, b, and c are numbers. What is the sum of them? Who can give me a hint, ya shabab, how to start? So we will start for sure with this, not with this. So we will simplify this and until we have it in terms of cosine. So what we can do about this, ya shabab? Who can give me this? This is equals to what?
You will have like two fractions.
Doctor, I'm seeing that there is a secant in the numerators. So for tan squared x, the other way to write it is secant squared x minus 1.
Allah yarda alayka ya Yasir. Yes, excellent, excellent, ya Yasir. So this is
Doctor, can you use the?
This is the first nice step. What about the numerator, ya shabab?
Can you make it like secant is u?
So what is that? What is that, ya Mansoor?
U squared plus 2u plus 1.
What is that, ya Mansoor? It has a name.
It's
X
quadratic
plus
equation.
all squared. What is that?
It's a quadratic equation.
Perfect square. It is perfect square. You know when you have x squared or when you have a squared plus 2a plus 1, this is a plus 1 all squared. The time is up, ya shabab. If you want to leave, the time is up, but let me just continue with you. This is secant x plus 1 all squared, so it is secant x plus 1 times secant x plus 1. And the numerator is what? The numerator is
minus 1
squared minus. No, I'm talking about the numerator.
No, yeah, numerator. You both
numerator,
wrote as
minus 1 times secant x plus 1. It is of
oh,
course
okay.
difference of 2. Now this will be cancelled with this, and we have secant x plus 1 over secant x minus 1. What is this? I want it in terms of cosine, not in terms of secant. So what I will do, I will convert this to cosine over 1 over cosine x minus 1. This will be equals to what? 1 plus cosine x over cosine, and this will be 1 minus cosine x. This cosine will be cancelled with this cosine, and if you compare this with this, what you can have? You will have a equals to what? 1, b equals to what? 1 again, and c equals to 1. And their sum is what? Their sum is 3, and this is of course the right answer. I will stop recording. See you tomorrow, shabab. If you have any question, of course,